Hello Internet, my name is Quinn and this is Blondihacks. Now if you followed me over the years, especially on my blog, then you know that I'm prone to some pretty stupid projects, but even on that scale, this next one is really stupid. So buckle up, because it's about to get weird. Let's say hypothetically your immediate family has 2 veterinarians in it, in which case you know very well the importance of toothbrushing to your dog or cat's health. Now with Sprocket, this is less an exercise in personal hygiene and more of a Thunderdome-esque battle of iron wills. However, after many months, she has gotten to the point where she'll mostly let me do this. This is a good time to remember that dogs we bred in every whimsical shape and size that we could think of, while cats we made as small as possible so they won't eat us. You probably noticed that that process involves a lot of protesting, chewing, and generally light attempted murder. But the problem is, if you do that every morning, pretty soon, you end up with a whole bunch of used cat toothbrushes. And you might ask yourself, well, why did I keep them all? And that's a very valid and reasonable question, which I'm going to decline to answer. But the thing I want to point out here is that there is a large end on the other side that's intended for dogs. And due to some obscure edge case in the global economy, the dedicated cat toothbrushes are more expensive than the combo dog and cat ones. So I keep buying the combo ones. So I got to thinking, this end, with a little bit of modification, could become this end, and I would double my toothbrush supply instantly. In fact, the shapes are actually very similar. The large end is just wider in every dimension. So if I were to put these guys in the milling machine and just make a pass on each side and then maybe chop the end off, round it over, I would have a whole new supply of cat toothbrushes. Now the challenge is that this toothbrush is a very weird shape. It's got a whole bunch of angles of crazy radii everywhere. It's a very complicated part. So if I could come up with some way to fixture this guy in the milling machine and make a pass on each side of this brush head, with a fixture, it would be very quick to do all of those brushes. So here's what I came up with to solve this problem. It's a fixture that I can put in the vise, and it will hold the large end of the toothbrush for a pass in the mill that will allow me to cut down one side, and then there's a smaller recess on the other side of the fixture that will hold the cut side that I've just done and allow me to cut the remaining side. And then there are 2 alignment pins shown in orange that keep the 2 halves of the fixture aligned as it slides in and out in the vise. And then in green and blue are shown 2 pins which go between the bristles on the brush and clamp it against the fixture. And then the angled section at the back will clamp down on the handle of the brush. So the idea is I can very quickly set it up in the vise and run through all the toothbrushes for one operation, flip it around, and then put all the toothbrushes in on the other side of the fixture and run them all through for the second operation. So it should be a very efficient way to convert all of my dog toothbrushes into cat toothbrushes once I've got it all set up. A quick sidebar. I can see a few of you out there doing the cost-benefit analysis of a project like this, furiously spooling up your angry comment machine, rage sweat dripping off your forehead onto the keys as you compose your masterpiece comment that will finally show the world how smart you are. Well, allow me to suggest that this may not be the YouTube channel for you. Also, I'm sorry that you value the destination over the journey and that someone took your joy from you. Now, back to your regularly scheduled stupid project. So I've got a nice piece of 6061 aluminum. This is a 2x4 by 6 inch chunk, and I got it off of eBay. The junk pile let me down this time. It's okay, I still love you. The fastest machine tool in the shop is the saw, so I'm going to use this guy to get our raw stock down to close to the final outer dimensions of the 2 parts. And I started this cut and realized I need to adjust the blade guide. Now for my other videos, you know I'm in a bit of a battle of wills with this saw in that I'm always trying to find a way to catch the piece as it comes off. And previously I had tried using a bucket, but I never seemed to have the bucket ready in time, so this time I was ready well in advance with the bucket, and then the piece didn't even fall down. So for this next cut, I tried something different. I used the handle of this chip brush to keep it from falling down, but without actually needing the bucket. And yeah. Now for this last cut, I'm kind of right at the limits of the vise here on the saw, so I'm going to go ahead and put a strap clamp on the back just to hold it down nice and tight. And this time I'm going to do nothing to catch the part. Go ahead, fall on the floor. I dare ya. Yeah, that's what I thought. We're going to start with the base of the fixture, which has kind of a slope on one end and these two weirdly shaped recesses in it, which hold the brush heads for the two operations. Now we need to square up this stock and bring the dimensions down to the outer dimensions of the part. And my go-to for this is my 10 flute 2-inch shell mill, but I've been having some trouble lately with it. As you may know, I've chipped a tooth on it and it's getting a little dull, so instead I'm going to bust out these really wicked 4-flute shell mills that were a gift to the channel from Dudley Toolwright, so check out his channel. And while my 10-flute mill looks very machine shoppy, these 4-flute mills look more like the subject matter of a straight-to-VHS 80s horror film, and I consider that a feature rather than a bug. Tappy tap tap. Okay, let's see how this new milling cutter does. Now, to be fair, this is aluminum, which you can pretty much cut with a frozen hot dog if your RPM is high enough, but you gotta start somewhere. Well, I must say, that is a fantastic finish. You can't really see it on camera, but it's got that kind of rainbow effect that you get on aluminum when you've got a really great finish, so I'm quite chuffed about that. Next, we'll try some side milling with this cutter, which should be an interesting test. I've never had good results trying to side mill with my 10 flute cutter. Because of the radius of the cutter and because the flute density is quite high, I can't really get enough tool pressure to get a good cut. And so you end up with those powdery chips that you get when the cutter's doing more rubbing than it is cutting. So with these much lower density flutes on the 4-flute cutter, should be interesting. It might actually work better. You know, that's actually not too bad. The chip action isn't quite as good as I would get with a much smaller diameter cutter when side milling. I don't have the long skinny chips that I'm looking for, but at least it isn't making snow. It's actually working pretty decent, so in a pinch, if I already had this cutter set up and I needed to do a little bit of side milling, I could probably get away with this guy. And let's try some more aggressive facing cuts. This is a 60 thou pass, and it's chewing that up like a champ, not even breaking a sweat. And those chips are coming off of there smoking hot. I have little burns all over my arms from where they were hitting me, but the cutter itself was lukewarm at the end of the job, so hot chips, cool cutter. It's a good sign that everything's working great, but I have quite a lot of side milling to do here. I really should have done one more cut on the bandsaw. I've got quite a bit to take off the length here, so I went back to my 1/2-inch roughing cutter and going to get aggressive with this guy and bring it down to size. And to do my last pass with a finishing mill, just to make sure I can show my face at the Barzy Bash next year. And here's our blank all ready to go after some deburring. It looks very nice, but yeah, I was having so much fun with that roughing mill that I kind of lost track of where I was, and I ended up blowing that dimension by 12 thou. So maybe I shouldn't show up at the bash after all. But not to worry, we can still use this part. I can push that error out into the sloped section of the fixture, which is much less critical, and it won't hurt a thing. To locate all the features on this part, we're going to do a mix of old school layout and DRO work. And so I'm going to get some blue on there, and we're going to start by forming this kind of shelf here. So I'm going to mark that out in the layout, honestly just as a sanity check, because it'll be easier to use the DRO to locate that shelf. And I'll just put an X on here so I don't lose track of what I'm supposed to cut. And I'm going to edge find one corner to get an origin, and then I can move the X-axis over by the size of our feature plus half the diameter of the cutter. And I'm going to go ahead and set an incremental 0 on the DRO so that we can hold this position if we need to come back to here. And it's always very satisfying to see as the cutter comes up and meets our layout line that we've done everything correctly. And, well, if it hasn't, then, I don't know, panic? Now our roughing passes are done. Let's see how much we need to take off for our finishing pass. We are at 150.5 thou depth so far, and oh, I love it when that happens. That's exactly what the Quill DRO says that we've taken, so that means that our touch-off at the beginning was actually incredibly precise. I'd rather be lucky than good every time. And the final depth we're looking for is 174, so we'll take that off in a finishing pass. The next feature we're going to make are these holes for the alignment pins, and it's going to be really useful to do these now for a later operation. So I'm going to spot these guys and then drill them undersize for an 1/8-inch reamer. We've already got the DRO set up, so it's really easy to locate these holes. So I drill them 1/64 under 1/8. And then I come back in with an 1/8-inch reamer. These pins are going to be made from 1/8-inch drill rod, so I'm going to start with reaming an 1/8-inch hole. And if that turns out to be a little on the small side, then I can open it up a little bit with an 1/8-inch oversized reamer. But what I'm looking for is a very gentle sliding fit on these pins. And we'll do a little test here, and yeah, that's perfect. I'm looking for that kind of feel where the pin wants to basically just fall under its own weight, but you can feel that there's no lateral motion in it, so that's perfect. Next up is this sloping surface here, which clamps the handles of the toothbrush. We're going to do this with angle blocks, so maybe this is the time that the angle block stayed in place in the box? Nope. I've got a 20-degree and a 4-degree angle block here because I need a 24-degree angle. So I'm setting them up kind of like you would with parallels, except that once your angles get high enough, especially with multiple blocks stacked up like this, you can't leave them in place like you would with parallels. They won't stay, and you can't tap the part against them. So you just have to seat them in there as best you can and clamp the vise down good and tight. And maybe don't get too crazy with your depths of cut because it's the part is suspended in space by the vise jaws. And our new friend, the 4-flute shell mill, is getting it done again, making a series of passes to bring down this angle. And when we get close to needing to meet up with the shelf that we cut, you could do a bunch of math and figure out exactly where this final pass needs to be, but I just did it by eye because it doesn't need to be perfect. Okay, that's starting to look like our part. So a little bit of deburring, and we're ready to move on. Yeah, it's looking pretty sharp. So our next operation is going to be to cut out this kind of funny wedge shape here. It's a recess, and this is where the large end of the brush sits for the first milling operation to reduce the size. And this is kind of an interesting thing that we need to cut here. There's a couple of different ways we could do it. One would be to set it up with angle blocks and mill it like so. However, the problem with this is that because the cross-section, of course, of an end mill is round, it's not going to leave a flush surface in here that we can then meet up with when we come back this way without cutting into this area down here. And the other interesting factor is that we actually kind of want a radius in there anyway, because the brush has a radius in that area as well that is very close to half an inch, or I guess a quarter of an inch radius. So the logical approach here seems to be to mill it in this position, and the end mill will give us that radius that we want in there, and then we can come back in from this direction to cut the remaining portion of this recess. Now the trick then is that we have to mount it flat in the mill, but at an angle, and so we can't use angle blocks like we would if we were milling a vertical angle. What this means is that we need a way to rotate the vise on the XY axis and around the spindle of the mill at an angle to make that pass. Now, I've made a bunch of fun of these guys in previous videos, these swivel bases for vices, but actually this would be the perfect tool for this job. As you can see, this one is currently serving two important jobs. It collects chips and it keeps this wall from blowing away. But I'm not super excited about having to remove my vise, install this guy, indicate it, and then reverse all that when I'm done this one operation. So I think we're going to try this a different way. Instead, I'm going to use this adorable baby little rotary table. This is a phase 2, and it's nice because I can stick it over here on the end of the table and not interfere with the vise, and I can just stick this guy on here, clamp it down, rotate it to the angle that we need, do one pass, and then I can just leave it where it is, rotate it back, do the other pass, and then I can even rotate it all the way around and do the similar feature that we're going to need on the other side. So this is going to be one setup, 4 operations, very efficient. The one gotcha here is going to be fixturing, so I want to use these holes to fixture it to the rotary table, which is why I made these holes first. And these are the T-nuts that I made for use on this rotary table, and they work great, except that they're designed for 1032 bolts, and those are too big to go in these little 1/8 inch holes. So what I'm going to do is make some new T-nuts with smaller hardware. So I've got this piece of steel scrap. Looks like we can get 2 T-nuts out of that. So I'm going to cut this guy down to size with the portaband and then square it up and bring it down to dimension. I'm going to do this last set of operations all in one setup, so I want to make sure that my parallel is going to be tall enough that I can cut the shoulders on the T-nut. So you can see I can line up an existing T-nut that I'm copying and just make sure that there's going to be material there and that I'm not going to hit the vise jaws. So now I can square up the top surface and bring it down to dimension, and then go in there with the roughing mill, cut my shoulders, and then drill the holes all in one setup. And you can see that I've left the part sticking out of the vise a little bit, so I can also face that end off all in this setup. Now to cut the shoulders, I need a center line, so I'm going to get my edge finder in here, and don't forget to deburr the part before using an edge finder, or you'll get skewed results. So then I can edge find on one side, and then zero out the DRO, and then edge find on the other side, hit the half function of the DRO, and then when I go to 0, I'm going to be right on the center line of that part. And then now I can come back in here with my 1/2 inch roughing mill, and I can offset by half the diameter of that cutter plus the distance that I want for half of the T-nut, and then dial in, let's say, a 40 thou cut, and start making some passes. Now I'm going to do this T-nut feature, the shoulder of the T-nuts, all with the roughing mill, and it'll leave a roughing mill finish on the insides of the T-nuts, but let's just call that an Art Deco detail. Now to make the holes, I need to offset from the end of the part, and I should have found this edge before when I had the edge finder set up, but I forgot, so here we are again. Now the first one's easy because I know where that edge is. The second one is a guess because it's, the one T-nut length plus half of the second T-nut plus a saw kerf, because I'm going to have to cut these T-nuts apart. But that's okay because I'm going to be milling the ends of these T-nuts to square them up and get them down to size anyway, so I just kind of was a little bit pessimistic with how far apart the holes need to be. Now as I go to drill these holes, a bunch of you are screaming at your YouTube players right now because, yeah, I left that parallel in the middle, and I had some trouble drilling, so I thought, oh, maybe my drill's getting dull, so I'll try the other hole, and that one went okay for a while, and then it was struggling as well, and yeah, that was about the time I realized I was drilling into my parallel. So as you can see, the damage is minimal, but I did have to stone down those apprentice marks, and my penance is to resharpen that drill and then finish the job. And then now I can come back and thread these guys for 440. And you can see how I set it up with some thin parallels to finish the job. And then it's time to cut them apart, and did my best to leave myself enough material on the end of each of the two T-nuts to square them up. And check out that dismount. Yeah. Now I can come back in and square up the ends of all the T-nuts and a little deburring, and there we have our two adorable little T-nuts ready to secure this weird looking part onto our rotary table. And in they go, perfect fit. And of course I had to make them short enough so that they wouldn't touch each other when the two bolts are in there in the same slot. And now we can square this guy up on the rotary table and get that guy locked down. Now that we know that the 0 that we show on our table is going to be our true 0, we need 22 degrees for this angle, so I'm going to dial that in and lock down the table. And then I always like to do a little sanity check, just bring the end mill really close to the surface and move the part back and forth and make sure that the edge of the end mill traces that line perfectly, just to make sure you didn't make any mistakes in this setup. And now we can touch off on the top of the part and then start making some passes downward. I'm establishing the depth first, and then once that's established I can go around and do all the other operations from there. And now quick deburr so we can check our depth. We should be close, and we're looking for 174, so we've got about 3.5 thousandths to go, so I'll dial that in and do my finishing pass. And now once our depth is established, I can just leave everything locked down right where it is and start doing side milling passes to bring this guy up to our layout line. And again, I could do a whole bunch of complicated math to figure out exactly how deep to make this weird angled cut, but I'm actually just going to mill up to my layout line by eye, and that'll get me within a couple thousandths of the dimension, and that will be plenty precise enough for milling cat toothbrushes. And now we can straighten up our table again, and I'm going to overshoot and come back a little bit because we're changing directions on the rotation, so I need to take up that backlash. And then I can lock down the table, and then we can do our tiny little straight cut that we need to do to finish up that weird shaped recess. Okay, moment of truth time. How'd we do? And that looks perfect. That's exactly what I was looking for. I can't seat it fully in there because the rotary table's in the way, but it's looking like this is going to work. So now I'm going to do the recess on the other side, and so I freshened up the layout fluid there, and I actually forgot to do the layout on that side, so I'm doing it in situ now. Luckily I have room here to do this and I don't have to upset my setup on the rotary table. And then this is the same operation as we just did, but coming in from the other side, and I'm using a smaller end mill this time. Once again, sanity checking my angle. So I'm coming in with a 5/16 mill this time because this is a smaller recess, and the diameter of the mill is once again setting the internal radius that we're going to establish where the brush head sits. So once again, I establish my depth, and then once that's locked down, I can come in and do my side milling and bring it out to dimension. And then once again, I square up the table and do the final little milling pass that's straight along with the axis of the part. And moment of truth for the small end, and that's looking really good. I think this is going to work. So I dismantled my setup and did a little cleanup with some acetone on the bench, a little bit of deburring, and that part is looking really good. Now let's do some test fitting with our toothbrushes now that we have full access. And it's looking really good side to side. Those are lining up exactly how I want, so we can make straight passes with the milling cutter. But let's see how it is on the other dimension. Here I didn't do so well. I kind of misjudged where that radius lands on the brush. It was really hard to measure that. So I think it's going to work okay because it's still going to clamp the brush down. It's it's flexible plastic, so I think it's still going to get the job done. But yeah, I was hoping for a better alignment of that sloped surface. But that is all the time we have this week. So thank you very much for watching. And if you're enjoying this project, why not hit me up on Patreon? And we'll see you next time.